And I'm going to be talking about MScribe. So MScribe originally arose when our team found the problem of finding accessible answers for lectures. So essentially the problem is that sometimes it's hard to get personalized answers for your lectures in real time. It's hard to ask questions about them if you can't make it to things like office hours or ask the professor directly. So we decided to create MScribe, which is a personalized solution for asking questions to your lectures. I want to do a quick demo of what people would do before MScribe, just to see why it's problematic. For example, if I'm watching this EECS 376 lecture, right? This is on something called zero knowledge proofs that contains exam info. Before, what you'd have to do is, for example, if I'm confused on what a zero knowledge proof is, I would literally go into my browser and type in, what is a zero knowledge proof? And now this definition could vary from school to school. It could vary from who's stating it. Maybe the professor at UMich, for example, Chris Pikert, has a specific definition that he would like to have used. And this knowledge is just not specific to the University of Michigan curriculum. But instead, what we can do here is now use something like MScribe. And instead of now having to do a Google search, we have an inbuilt solution to figuring out questions that you have, or asking questions and figuring out comments. So just to do a quick demo of this, the first thing we can see here is that we have a timestamps feature. What this does is it gets us a real-time summary of what the lecture is about. So this will take a second to load in. Let's see. Cool. So right now we get all the timestamps. We get what information is presented at each time. So for example, at 1:12, if we go right here, let's see, right here, we can see that there's a final exam info discussion thing. So now we can see exactly how our lecture is templated in terms of time. And in addition to that, we can now ask questions about our lecture. For example, I could ask, what is a summary of this lecture? And it will give me the summary. It'll say this lecture is focused on zero knowledge proofs. MScribe is automatically trained as soon as you open the lecture and you open the extension. It trains itself and it stores the data in a database. And now essentially we can ask other questions too. For example, I could ask here, maybe I'm confused on what zero knowledge proofs are, right? So it says a convincing demonstration. We could ask, what does the lecture mean by convincing demonstration, right? And it can specifically answer with context. So here it says it refers to the methods that effectively show differences or truths through examples. Maybe we could go to somewhere like this, right? And maybe we don't know what a Hamiltonian cycle is. So then we could ask, what is a Hamiltonian cycle according to this lecture, and how is it used, right? Now this will answer a Hamiltonian cycle is a path, right? And now it explains that it's used in a theoretical scenario where one party, Merlin, demonstrates the existence of such a cycle to another, Arthur, right? And that's specific to this lecture. We've essentially scanned through the entire lecture and stored all the data in a database, and now we can ask questions using that type of context. Let's do one more example. Let's go anywhere we want. We could go maybe here, right? We have these two scenarios here, the electronic money scenario and the group signature scenario. And then maybe I'm confused on how it specifically applies to group signatures. I could ask it, how do zero knowledge proofs apply to group signatures? And we can see here that it gives us an accurate answer that takes in the context of the lecture. Cool. A bit of the higher level product architecture of what MScribe is. Essentially, MScribe is built in React using a library called Plasma.js. So Plasma allows us to compile the React as a Chrome extension. And now what we do is, whenever we open up this extension, we essentially scrape this unique lecture ID, which we will use to later mark the lecture in our backend. So this lecture ID is unique to this lecture, which means we can store all the context related to this lecture. Now the area we actually get the context from is actually the Kane API itself. So if we go here and I reload this page, we will essentially find the transcript within the API itself. So here we can see that our browser is making a network request and we get this huge piece of context. And now this file is several thousands of lines. So it's 5,000 lines, and this contains all of the audio used in the lecture and all the respective timestamps. Now what our backend does is we're going to essentially chunk these and turn them into vectors and store the respective pieces. So like for example, something like this, it would turn into a vector, and that's going to be stored in Pinecone. So to dig a little bit deeper into that, we can go to Pinecone. So let's take a look at this lecture ID we have here, AA4PN2. We can go to our Pinecone index. Essentially we'll create something called a namespace in Pinecone. And what that essentially is like an index that we use to keep track of all of the context for this individual lecture. So now here you can see the things we've chunked. For example, this is one chunk right here. You can have for the final exam, two-sided, ordinary size study sheets that you prepare yourself. So the exact same policy as for midterm. So what's gonna happen eventually after that is whenever a user asks a question right here, it will be converted into a vector, say something like this, right? And now this vector is essentially compared to all of these vectors in the Pinecone database or data store. And then for the closest ones, we will essentially pull the associated text with them. So it's the equivalent of essentially making a ChatGPT prompt and using an LLM with this essential context that would have been copy and pasted into the LLM. So just imagine if I asked a question about the cheat sheets, this text here would essentially be pasted in to like a chatbot, and then you ask your question underneath that. So it's essentially implicitly getting the context. In addition, what the timestamps feature does is that it essentially goes through the entire lecture, and it makes that same API request that our browser would have made, and it displays that after processing it through an LLM. So now that we've done like a high-level technical overview, I want to dive a little bit deeper into like how we built it. So on the left-hand side here, you can actually see the React code for the Chrome extension. Essentially, we have some state variables here. Some important ones are this PHP session ID. This is essentially the token that allows us to make that request for the transcript. And then there's also the lecture ID, which we set, and we extract both of these from the pages, as you can see in this extract lecture code function and this fetch PHP session ID function. So the lecture code is used to keep track of like all the context. It serves as a unique index for the lecture we're currently referring to. And now essentially when that lecture loads in, we can use this use effect. So essentially whenever you open the Chrome extension, it automatically syncs it using this post lecture function. So now using that lecture ID and the session ID we get, where we essentially call our backend, and our backend processes all of like the code and it posts it to the Pinecone database. And that way we get the context in the database automatically. Some problems we ran into here was figuring out what token actually we could use to make API calls to get the transcript. To some extent, there was a little bit of a guess and check process here. There are several tokens and different types of cookies used in UMISH's security processes, so we really had to go through each one and test it individually to figure out which one correlates with it, especially because this is more of a private API and it's not supposed to be used by the public intentionally like this. We honestly found a quite creative use case. Now essentially, we store that data, and we also have functions to essentially handle sending the data. Something also challenging here to implement was essentially keep maintaining like the state of the messages. Here you can see that we created a custom array object that would render the messages too, so that was challenging. In addition to that, a lot of like the complexity was actually on the backend side. So to do a quick walkthrough of our backend, we essentially used Fast API, which is a Python backend library. It creates an HTTP server. And essentially we have two main sets of routes. We have things called the scraping routes. This is how we get the transcript. We essentially make an API request to the Kane lecture API. And essentially we are passing in that cookie we got earlier, aka the PHP session ID, and also the Kane ID, which is the unique lecture ID that we found earlier. And through that, we're able to make an API call to the lecture and get the transcript that we can later use. And then with that transcript over here, what we do is we get the raw transcript. I do a little bit of text processing to make it a little bit more usable. So I parse it, and then I delimit it, aka break it into chunks, and then we process it and post it to the Pinecone database. that is all implemented in here. So all of that chunking, ensuring that the index exists before we post data to it, and then embedding them, and then creating the namespace. All of this is done using these Python scripts here. And essentially, this efficiently allows us to chunk the lectures, transcripts, and then essentially post that and the equivalent vectors to the Pinecone database. Now, essentially, when a user asks a question, we actually hit our RAG routes. RAG stands for Retrieval Augmentation Generation, which is the overall technique we're using. Essentially, we just get the unique query, aka what the user types in. We take in the unique lecture ID, and then we're able to get the chat context based off of those two. In addition, we also get the actual chat context of the messages beforehand. That way, if a user asks multiple messages, they get the appropriate response, right? That was a little bit challenging to keep track of because we were keeping track of prior messages. And then essentially after that, we took advantage of a cool library because it is hard to get a proper structured output to use in your application. We had to do a little bit of research, which was difficult. We found a library called BAML, and now what this essentially allows us to do is it essentially lets us get the correct formats for the data we're using. So we had to do a little bit of custom structuring here. So we set the base classes for what we want all our data to look like when it comes back. So essentially when we get a response from a query, it should be a string. If we get a timestamp response, we set the time as a string, the title as a string. This way we know exactly what type of data we're getting back from an LLM, and we can use it in our app very quickly. Overall, a lot of the challenges in this project were mainly technical. We had to learn how to navigate the Cane infrastructure that the school has produced. We had to figure out how to manipulate the cookies that they had available to be able to make these API requests. We also had to learn how retrieval augmentation generation worked. And yeah, that was the primary challenge. Something else we also ran into was environment management. So we're using a Python backend, therefore we have to use a virtual environment to keep track of our packages. So a lot of the things that were imported here, for example here, these clients, these are all Python packages, right? So in our backend, we actually did keep track of an environment right here. So we have our keys for all the services we use. We also kept track of a requirements.txt file that kept track of all the packages. We ran into several dependency conflicts, so we had to test these multiple times over and over and do a topological sort to make sure all the packages work together. Yeah, just to summarize the product, essentially, MScribe makes it easy to watch your lectures. It makes it easy to get real-time answers to what you're confused about. And from a technical aspect, most of our problems are technical. They largely were nitty and gritty. They involved working actively with the code base. And yeah, a lot of them were minor technical problems that did delay how fast we were able to get the product out. But essentially, yeah, we were able to get through it, and now watching lectures is easy.